So most of you did a pretty good job on this one. You were just thrown off by the word inclusive, which means it's going to include 41 and 50. So if we list all the numbers from 41 to 50, we want to include both 41 and 50. Then we're going to cross off the ones that aren't multiples of 2, 3, or 5. So that means that 2, 3, or 5 do not go into them. Then what we're going to do is add up these numbers. A really quick and easy way to add them up is to notice sort of friendly numbers. For example, these two together equal 90. These two together also equal 90. And then these two are 95. So really, we're just adding 90, 90, and 95, which 90, 90, and 90 is 270, plus the 5 is 275. So if you got that one wrong, most likely you got it wrong because you did not include the 50. With this one, there's a few different ways you could do it. You could get common denominators. You could figure out what each bracket is, and you could subtract. One really quick thing, if you notice, 3/5 is really like 6/10, right? And that is double 3/10. 67 500ths, you look at that, it actually ends up being double 67,000. So this one is twice as big as this one. So really, if I take something and I take away half of it, I'm left with the other half. So really, because this one is twice as big as this one, this is what I would be left with after subtracting. And this is really like 300 over 1,000 plus 67 over 1,000, or 367 over 1,000, which is the same as 0.37. You could easily have gotten a common denominator. You could have made this one 600 over 1,000 plus, and you could have made that one, I think it's 134. And then you could have subtracted from, you could have gotten 734, take away 367. You'd still end up with that same answer. It's just a little bit quicker to notice that one is twice as big as the other. This question, one of the easiest ways to approach it is to use right-angled triangles. So for example, I could create a triangle right there. I could create a triangle right there. I could create a triangle right here. And then I have a square left in the middle. And then all I really need to do is find the area of each. So the red one has a base of 1 and a height of 3. The green one has a base of 1 and a height of 1. The blue one has a base of 1 and a height of 2. And then the square is just 1 by 1. When I go through this, I end up with 1.5, a half, 1, and 1. When I add those together, I get 4. And that's the area in square units of that figure. This next one, most of you are actually really close on. What you have to remember, though, is that each letter represents a different digit. So if I choose something for the letter C, I can't use that same digit for a different letter. Likewise, if I choose something for letter P, everywhere that P is, I have to use the same digit. So your goal is to get the smallest possible answer. So where you should start with this, to get the smallest answer, P should be 1. So we can start by putting in those ones. Right away, 1 plus 1 is 2. So now we know P is 1, and we know that T is 2. Then you actually have kind of a couple choices. You could go to U next, or you could go to C next. So I'm going to go to C next. So I need to think about what's the smallest thing that will give me a 1 in front. Well, that's actually going to be 10. And that means C needs to be 5 plus 5. Then I'm left with my U's and then my N. This is where most of you went wrong. You were thinking, well, to get the smallest thing, oh, you should be 1 and 1, except it can't be because P is already 1. Then you thought, to get the smallest thing, U should be 2, except it can't be because T is already 2. So the next smallest number is going to be 3, and that will make N 6. That is the least possible value when each of those different letters represents a different digit. So just be really careful with that. A lot of you were so close on that and just made a couple little mistakes to throw you off. This last one, most of you, I'm going to show you kind of an approach that most of you use. Most of you listed all of the different possible arrangements, which is totally fine. You had time to do that. One thing to watch when you're doing that is make sure you have them all. And I think if you made mistakes, you either made mistakes in either your addition or you made your mistakes in forgetting a number. So remember, if we have 4 digits, there's 4 possible digits for the first place. We have 3 digits left for the second place, 2 digits left for the next place, and 1. So there's actually 24 arrangements that are possible. So if you are going to list all the numbers, make sure you know that, so you know that you need to list all 24 numbers and then add them all up. Now, you can also be thinking about patterns here. What you're going to realize is that if there's 24 arrangements, there's actually 6 times that the 4 ends up in that place. There's actually 6 times the 4 ends up here. There's 6 times the 4 ends up here, and 6 times the 4 ends up here. Likewise, there are going to be 6 times the 7 shows up, and 6 times the 1 shows up, and 6 times the 5 shows up. So you might wonder, why is that important? Well, that means each place adds up 4 plus 7 plus 1 plus 5. We end up with 17. And that means each of these place values all will add up to 17. And that happens 6 times. So 6 times 17 is 102. Then what you can consider is that what is the value of each of those places? Well, the first place is worth 1,000, the next is worth 100, the next is worth 10, and the next is worth 1. In total, that's going to equal 1,111. Then each of those was adding up to a sum of 102. So really, one way to do this really quickly is to just do that calculation right there. And that comes from using patterns. When you do that, you're going to get 113322. And I know that's a little confusing and you might not like to use that, and that's totally fine. But what you can see, as I said, is you know there'll be 6 4s here and 6 7s here and 6 1s here and 6 5s here. So this total, this place value adds up to 17. So does this one, so does this one, so does this one. And that repeats 6 times. So 6 times 17 is 102. Then the actual value of those numbers, when there's a 4 here, it doesn't really equal 4, it equals 4,000. This doesn't really equal 7, it equals 7,000. So the place values all add up to 1,111. If you just multiply those two, so it's maybe a slightly faster way of getting to the answer.